All right. So today we're going to talk about containerization, or the concept of the general concept of containerization. And hopefully we're going to have some exercises creating container images. And now, did you hear about containers before? Did you hear about the concept of software containers? Kind of, yeah, a little bit. It's becoming more and more popular, and the reason I wanted to introduce it that early, like second year, that early, because there are a lot of opportunities that are available for students that would be easier for you to pursue these opportunities if you understand the concept of containers, because it is already popular in the industry, and it would give you advantage if you learn it as early as possible. Okay, so so far we learned about how to develop, right? How to create the container. I mean the application. Okay, but in order for the application, the software application to be useful, it has to be deployed, has to be put into actual use, right? Now, there are some problems. I will start by introducing the motivation of the containerization. So I'll start by introducing what led to the concept to begin with, and then we are going to understand the concept itself. All right. So do you know what is a software dependency? Yeah, software, yeah. You know? Okay. You understand the concept of software dependency is anything that your software depends on in order to execute properly. So that could be another library, for example. So for example, your application depends on Pygame, right? It might depend on other files, like the existence of the asset files, for example. It might depend on some configuration or some environment variables. Okay, so anything your system depends on in order to execute properly is what we call the software dependency. Okay, now the least of it, the most obvious of it is that, like, when we are creating this game, we need to have Python installed. That's a major dependency, and we need to have Pygame library installed in it, right? And then our application can run. Okay, now the problem with software dependencies is that if you have a real application, oh, it's not advanced. Okay, so that's the concept of the software dependency. Now that's a simple example of a realistic dependency graph. Now you see, it's very hard to read, right? So even if you try to zoom in order to read it, even harder, like we try to zoom in here. Okay, you can see part of it. So it's just what module depend on what module, and then dependency can be circular, and even when you zoom in, it's hard to read and hard to see the entire picture. So that's just a simple example of one somewhat realistic dependency graph, which is hard to read. You see, it's hard to manage as it is hard to read. Now, let alone that, like, we're not able to read it. How are we going to manage it? Now, the problem happens when you move your software from one environment to the other. So realistically, if you have a software house, you will have to move your application between at least 3 different environments. So you have the development environment in which you create the development happens, okay? And then you have the final destination. That's what we call the production environment. So production is where it is put to use. So if it's a web application, then it's deployed on a web server. If it's not a web application, then it is installed at the customer site. Okay, so the production environment is the final destination in which the software is put in actual use. Okay, now typically you would need to test it before you send it to production. So generally speaking, there would be at least one testing environment. So you're moving from development to testing, and then from testing to production. Now, this movement is like metaphorically described as shipment. You are shipping your application between the environment. And the very common problem that happened during this movement is that some dependency might get missed, might get dropped, like a file might get corrupted, might conflict with another file in the new environment, so it doesn't work anymore. Okay, so the phenomenon that a lot of people talk about, the phenomenon is that it works on my computer. Okay, so what works on one computer or in one environment doesn't work in another environment. Or like you develop the software, moved it to testing, and it works perfectly, and then when you go to the customer side, all of a sudden bugs appear. Okay, so it behaves differently between different environments. So in order to solve this problem, people borrowed from the concept of containers in the literal shipment industry. Okay, so the literal shipping of literal products before the introduction of the concept of the physical container used to happen like loose, like you can put like furniture or whatever you are shipping together, so things can get broken, they can get messed, they can get mixed up with other people's work, with other people's shipments. All right, and then they invented the concept of the physical container, like the actual container, that made the industry of the shipment much easier because it has a standard size, so you know how many containers your ship is gonna take and which weight, and also the fact that it encapsulates the products, protect them. Okay, so they don't get missed, they don't get mixed up with others. Okay, so now the concept that's a concept of literal containers from the literal shipment industry was borrowed, and the concept of the software container that is used for shipping, the metaphorical shipping of the software, is now becoming a very popular concept. Okay, now Docker is one of the most popular companies that provides a containerization system and products. Okay, it's almost synonym to containerization. So when you say Docker, it is pretty much the same as saying contain. That's because it's not the only company out there, but it's the most popular. Now you can see the logo of Docker is pretty much motivated by the original motivation of the concept to begin with. So this whale is pretty much the ship and the software container on top of it. Now there are different variations of that logo, okay, but it's pretty much the same concept. Okay, so what happens in the software containerization? We have four main components. One is the container runtime engine, and then there is a container itself, and then there is a container image, okay, and then there is what we call the image registry. Okay, so four main components. Let's start by the container itself and the runtime engine. Okay, so if we are going to compare running an application that is containerized by running like a regular application, so your regular application will need to have the dependency installed, so you make sure that all the dependencies are in place, all third-party libraries are in place with the right versions, and then your application is installed in them. Okay, it's not as easy as it looks, because they're like oftentimes one installation, when you attempt it, it conflicts with something else on the system, or it's very difficult to do this, like to have the dependencies installed manually or even with a script. Okay, But if this is how it's gonna work, after you install them, they would run directly on top of the operating system. So the operating system is responsible of the execution of the actual application. All right. Now, when you use a container, the container packages your application and its dependencies. So you don't need to install them on every location in which the container, like the application needs to run. You just install them once in a container image, and then you just copy this image and run it. You don't need to go through the installation stage every single time you need to run your application. Okay, so the container will be encapsulating everything, the application and everything it needs. All right, and it needs to run on a runtime engine. So it's pretty much very similar to the concept of virtual machine. If you experience that working with a virtual machine, like if you have a Mac, for example, and you need to run a Windows-based application, what do? You install a Windows virtual machine, and then you run install the application on the virtual machine, right? So the container runtime engine is very similar in concept. A lot of people confuse them, but we cannot say the runtime engine is a complete virtual machine. You can think of it as a very lightweight virtual machine. Like there are some functionalities in the containerization system that overlaps with the concept of the virtualization, but it's not exactly the same. Okay, so the container is much lighter than having a full virtual machine. Okay, now we can see this comparison if we look here. So this is how the virtualization would look like. Okay, so you would have your own operating system, let's say like the Mac OS. Okay, and then you install the virtual machine, and then on top of the virtual machine there is the entire Windows operating system. That's a lot. Okay, and then you install your application the old way, so you are responsible of installing the dependencies and the libraries, and all the problems that we talked about are still present here. It's just that you're not tied to this the original operating system. Okay, now the containerization, you see, it looks similar to this, but it is much lighter than having the entire operating system running, and then you have your application on top of it. Okay, well, in fact, there is like when you create a container, you include a miniature version of the operating system that your application needs. Okay, but it's minimal, like it's only what your application needs, not the entire operating system. Okay, now sometimes you need to have both. Sometimes you would have a virtual machine that has its own operating system, and then you want to run a container on top of it. And that's actually what happens if you have a Mac or a Windows, because the Docker, so when we work with Docker was built for Linux, you're gonna need a Linux virtual machine. So it's pretty much what the mixture model is what we'd be working with. Unless you have a Linux, then you just need to install the runtime engine right away. All right.